Good morning, class. Today we're looking at matrices. This is a little bit different than what we've been talking about. What is a matrice and how can we kind of formulate them? We're talking about rows, columns. If you've ever done anything like ordered shirts for an organization, you might have had the chance to look at matrices in your real world practices. We'll see. So a matrix is a rectangular arrangement of objects. We call these objects elements. We've heard that term before. They can be used to store information or desirable transformations, or describe, I should say, transformations. A matrix with m rows and n columns has the dimensions m, x, n, or m by n. And so we look at rows and columns. We can describe our matrices in that way. Let's start with this. First off, storing information. I've done this before where, like for volleyball, if we order hoodies or sweatshirts or t-shirts or whatever the case may be, I have to send in an order and I do something along these lines for how many of the different sizes I may need. So you can see here, I need 9 small sweatpants, 10 small sweatshirts, 8 small shorts, 18 medium sweatpants, 20 medium sweatshirts, 19 medium shorts, 20 large sweatpants, 24, etc., etc. So you can see matrix can kind of help us to sort information. How do we graph a matrices? So you can see here with this matrix, we have a set of ordered pairs, x's and y's. So one of our points is 0, -3. Another point is 6, 0. Another point is 4, 7. Another point is -6, 4. So we can graph this group of ordered pairs in this matrices. Now, when we talk about adding matrices, there are kind of some simple rules here. You can only add matrices with the same dimension. So they have to be like 2 by 3 or 4 by 5 or whatever the case may be. So here we see again, rows and columns, a 2 by 3, 2 rows, 3 columns, plus another 2 by 3. So with these two matrices, we can actually add them up. How do we get these numbers? Well, you take 4 plus 1 to give you 5, -2 plus 4 to give you 2, 7 plus -6 to give you 1, 3 plus 1 to give you, that didn't work out. Yeah, there's a typo on there, sorry. 6 plus 7 to give you 13, 0 plus -3 to give you -3. For solving for A and B, you can see here, we can solve then using the understanding. So if 10 minus 6 will give us A, that means A must be 4. Looking for B here, B corresponds with 7. 7 minus -5 gives us B, so B must be 12. So that is how we use addition in matrices. Subtraction in matrices, similar kind of concept. Again, same dimensions. They have to be the same dimensions. So these two here, rows and columns, we have 3 rows, 2 columns. So these are 3 by 2s. 3 by 2s. So in this instance, we're going to take 4 minus 9 will give us -5. 1 minus 0 will give us 1. 5 minus 5 will give us 0. -3 minus 2 will give us -5. -6 minus -6 will give us 0. And -2 minus 7 will give us -9. Similar concept, we're solving for the letters A, B, C, and D. We just have to know that A minus 3 is 9. So we solve that piece. And then -1 minus B is 0. So we can use that information to find that A is equal to 12, B is equal to -1, C is equal to 19, and D is equal to 6.5. As we look at the next stages or steps, we can talk about scalar multiplication. Each element in the matrix is multiplied by a scalar number. Kind of like you can think of parentheses out in front. This would be if I need like an order of hoodies, shorts, and shirts, but I need 5 times of that, I can multiply it by 5. When I do that, I just basically distribute this 5 into all the different parts. 5 times 7, 5 times 2, 5 times -1, 5 times 4, 5 times 9, 5 times 11 to get this matrix. In the same way, we can solve for A and B utilizing the same skill set. So we need to, in essence, scale this 4 into this matrices and this -3 into this matrices, and then solve it. So when we do so, we get 14. So now we can solve for A and for B. So A is 6.5, B is -1. Lastly, when we talk about multiplying a matrix m by n, with a matrix n times p, the results of the matrix will have the dimensions m times p. Now, the only key here is that the columns of the first matrix has to be equal to the rows of the second. The number of columns in the first matrix must match the number of rows in the second. So in this example here, we have 2 rows, 2 columns. Here we have 2 rows and 3 columns. So this, when we multiply it together, will wind up being a 2 by 3 matrix. As we do our multiplication here, you can see we have the same numbers here. We do 8 times 1 plus 2 times 0. That's where this rows and columns kind of fits in. 8 times 1, negative 2 times 0 gets us 8 plus 0. The 8 we got from 8 times 1, the 0 we got from negative 2 times 0. So 8 plus 0, so that goes here in this first box. The next one, we do 8 times negative 2, 8 times 3, negative 2 times 4. We summize that, we get 16. So 16 is the next one. And then we keep moving on from there. Okay, so we would do 8 times 36, negative 2 times 22 to find the next one. So as we calculate and find these out, we can keep adding them to this new matrices that we're building. So here are a couple examples for you to take a peek at. You can pause the video and work them out on your own. Remember, you're going to go 5 by 4, 4 by 2, 3 by 0.5. That's going to be our first one. 6 by 4, 5 by 2, 2 by 0.5. That'll be our second one. Okay, so if you have any questions on this, especially with this multiplication part, go back and review that section in the reading. There's a couple more examples you can kind of work through for that portion, specifically on page 368 and 369. So here's your homework. Read pages 364 to 371. Your homework's on 371 to 374, and we'll do these numbers for our homework for this lesson, 7.3. We'll see you guys in class.